Okay, so hi and welcome. Can you hear me?
Hi. Yeah, I
Okay, so
hope you'll be
just we are
fine.
waiting 1 or 2 minutes for joining all of the other participant. Then we'll start our today's session. Okay, just we are waiting. Okay, so now we'll start our today's session. So basically today is our fourth number of days for Google Earth Engine online training program for remote sensing analysis. So basically today I will try to discuss about that how we can easily make the land surface temperature monitoring using Landsat imagery in Google Earth Engine platform. As we'll also talk about the DEM dataset, a digital elevation model dataset, and also make the different types of DEM analysis, such as for that how we can easily make the hillshade map, salt map, or aspect map. Okay, as well as we also try to discuss about that how we can easily remove the cloud from the satellite images. It can be Landsat or Sentinel. However, any types of satellite images, how we can easily remove the cloud, not only for the cloud, a cloud shadow, or other types of unnecessary pixel value on satellite images, and get the very clear satellite images on Google Earth Engine platform. Okay, so let's go. Just I simply share my screen. So now can you see my screen?
Yes, it's visible.
Okay, so it's okay. So first of all, I talk about that how we can easily remove the cloud or cloud shadow from the satellite images, such as Landsat and Sentinel image. How we can easily remove the cloud. Then talk about that visualize the DEM dataset. Basically, there are a lot of DEM dataset is available in Google Earth Engine platform, STAR, as well as also available for the NASA SRTM dataset. Okay, so this type of DEM dataset, how we can easily use and make the different types of hillshade map, salt map, or aspect map. Okay, in Google Earth Engine platform. Then we'll also try to discuss about that land surface temperature monitoring from the Landsat satellite imagery, and how to calculate average, maximum, and minimum NDVI for any specific region. Okay, so basically, this content, how to calculate average, maximum, minimum, uh, pixel value So this content, previous class I talk about that. Okay, so I show you the process how to calculate average, maximum, minimum, pixel value for any specific boundary. You want to calculate the average, maximum, or minimum, NDVI, NWI, or anything, or any indices, how you can easily calculate. So this topic I already talk about that. Okay, so now let's go start. So first of all, visualization DEM of Hillshade and salt map. How can you create the Hillshade map, salt map, or aspect map in Google Earth Engine platform using the NASA SRTM dataset, DEM data, NASA SRTM. And you can see simply we download the tip images from Google Earth Engine platform, and then make this map in ArcMap software, such as we can easily add the legend, also title, scale, north line, all of this you can create in here. So now I talk about that, how we can easily work with the DEM data set in Google Earth Engine platform. So for that, first of all, I just simply open a new code editor. And simply search here NASA SRTM. Okay, so here I can get, you can see NASA SRTM digital elevation. It's the resolution is a 30-meter resolution, and we can get the dataset for the global dataset. It's a global dataset, and you can see the one band is the elevation. Okay, only for the one band is available elevation, and this unit is that meter. Okay, so in this time I use this dataset. So first of all, I simply click on the import. You can see import. This dataset is the imported. So in this time, here you can see it's the image. Okay, so it's a not image collection. Okay, so it is only for the single image. Okay, so mainly we already talk about that filter bounce function, as well as the filter metadata function, filter date function. All of this function is only applicable for the image collection. Okay, such as Lancet image collection, Sentinel image collection, Modis image collection. Okay, but in this time it not a image collection. It's such a only for the single image NASA RTM DEM data set. Okay, so in this time it is single image. So that's why in this time we are not apply any types of filter function, such as filter date, filter metadata, or filter bounds. We can directly display the data. Just use our map dot add layer and call this variable name image. So just call the variable image. So now click to the run. In this time, you can see it visualize the whole world DEM dataset. Okay, so in this time it show the grayscale. You can see I get the result as a grayscale. Okay, but I want to show the some distribution, high and low elevation. So for that, I simply set here the visualization. So I set the mean. This elevation will be start from. I show the visualization for 0 meter, such as max, such as up to 300 meter. Okay. So now click to the run. In this time, we also get the more visualization. You can see in this time the white color pixel value or white color identify the highland and high elevation, and low elevation show as a black color. Okay, if you want to check about the data set, suppose click on the inspector tab and click on here for the white pixel value. I can get the 4805 meter elevation for this coordinate. Okay, so if I check on the black color, this you can say I can get the result only for the 14 meter. Okay, click on here. Okay, so in this time we can get the some distribution about that elevation data. So we can also add the more visualization with the color. Suppose I set the color such as the color plated. Suppose I set the color plated such as blue. Then suppose put here the yellow. and high elevation I want to show as a red color. Okay, so now we also get the more distribution about the DEM dataset, elevation dataset, you can see. Okay, so now in this time, the red color is identify, it is the high elevation. Okay, and yellow is the greater less than red, and blue is the lowest elevation. Okay, suppose I click on here, I can get this high elevation. Okay, but when I click on the blue, it's showing the low elevation. We can get the 20 meter only for that coordinate. Okay, so in this time it visualize the DEM data for the whole world. Okay, so now using this DEM data, I want to make the hillshade map. Okay, so that I can easily identify all of those hilly region. Okay, as a 3D view. Okay, all of this 3D view, I want to display the hill region. In this time you can see there is the no hillshade. Okay, I did not identify this is the hill or hillshade. Then it's totally flat. It's showing the totally flat. But when I show the hillshade, then this hillshade showing as a 3D view. Okay, so I can easily identify this is the hilly region, this is the hilly region. Okay, all of this hilly region I can easily identify from the hillshade map. Okay, so now how I can create the hillshade map. Okay, so for creating the hillshade map, first of all you have to take a variable name. Suppose I put the variable name is that hillshade. You can put any variable name, there is no problem. And then use here a function dot train dot hillshade. Okay, so mainly this function created the hillshade map. Okay, dot train dot hillshade. Then you have to input in here your raster image or your DEM image. So in this time, I just simply put here the my DEM image is that you can see. This is my image of the DEM. Simply copy the variable name and paste here. Okay. So now display the hillshade map. So just add here the visualization. Just as map, add layer. Put here this variable name hill shade. So now click to the run. Okay, in this time we can see we can get the some 3D view in here, but it's not more better. Okay, so in this time when I apply the visualization also in here, then we also get the better visualization about the hillshade. So now I simply put here the mean. It will be start as from 150 meter. Okay, there is a no constant below. I just simply use this minimum and maximum range and then visualize my map. Okay, 150 meter, and then max I put the such as 255 meter. Okay, so using this range I want to show the hillshade. So now click to the run. In this time we also get the better visualization about the hillshade. You can see. So in this time you can see the hilly region, and it also you can also get the better view when you can simply you can see there's the two layer. One is the hillshade, another is the DEM. So you can simply click on here, and then you can simply you can see just click on here, and then simply you can see when you can simply you can easily identify about that. Okay, so I simply reduce it from here. So now by all of the silly region, this is the 3D view from the DEM data working. You see the hilly region. Also, this is the hilly region. So all of this hilly region we can visualize as a 3D view. You can see this is the hillshade map. Okay? Only for the hillshade layer now opening. Only for the hillshade map. Okay, and here I already add the another layer for the DEM, which is showing the red color is the highest elevation. So when I open that, then we can easily get this red color look like that. So it is the hilly region. You can easily find out that from here. Okay, so in this time, suppose we can create the hillshade map using the e.print.hillshade, this function we are using, and create the hillshade map for showing the hillshade area as a 3D view. Okay, so now I want to create the salt map. So for that same approach, take the variable such as, and then use the function e.print dot salt. Okay, and then simply call your image, simply copy that and paste here. Okay, if you want to know the more description about that, simply copy this function and go to the docs tab and click on here. So you can see the solve function. Click on here. So in this time, calculate the solve in degree from the train DEM. Okay, so in this time, I calculated the solve. This unit will be degree. Okay, so this function when I use, then it automatically create the solve, and this unit will be degree or angle about the degree. Okay, so from this train DEM. Okay, so in this time I display the result first. So simply use at the map add layer, and then simply copy this variable name and click to the run. Okay, so in this time you can see default visualize about the solve as a high solve, as showing as the white color, and also low solve as showing as the black color. You can see, but you can also change the value for the min and max for the better visualization. So for that, okay, first of all, I check the result. Suppose I click the I click on the any portion. Suppose I click on here. Suppose for this region, I want to check what is that all of this value. For this region, I can get the 4,111 meter elevation, and for that we can get the hillshade value is the 137 meter hillshade, and we can get the slope is the 22 degree. Okay, 22 degree for this coordinate. Okay, so 22 you can see for this region I can get the 22. Okay, so in this time I simply add here the mean and max value of the solve, such as suppose make this mean, it will be start from such as 10 degree to max, such as suppose 25 degree. Okay, so now display the result, then we can get the better visualization about this friends for the solve area. Yeah, so now I can see it showing the result. So mainly hilly region we can get the high solve. Okay, so mainly hilly region we can get the high solve value, and the flat region we can get that low solve. Okay, so you can see all of the hilly region. So in this time I just simply yeah, yeah. So in this time you can see we can get the high solve for this all of the hilly region. Okay, white color identify the high solve in this time. Okay, you can see the high solve region for the hilly region we can get in here. And for the low area or flat area, there is the no solve about that. It's a totally flat, not angle. Okay. Okay. So any question you can ask me about that.
So, what is the difference between hillshade and slope?
Okay, solve is the mainly identify about the angle. Okay, suppose when you want to go
Yes.
to the hillshade, what is the angle between that plane surface from your hillshade area, okay, hill area or hilly region? How many angle it will be in the from the floodplain? Okay, and hillshade mainly it's identify about that hilly region. Okay, so hillshade is identify the hilly region. Okay, and in this time from the DEM, you can see this is our DEM result, this is our DEM map. We can identify this is the highest elevation for the red color, but I did not find out any it's a hilly region, but when I want to visualize the hill region, then I have to use the hillshade. Okay, I need to create the hillshade map. Okay, and hillshade map mainly it visualize the hilly region as a 3D view. As a 3D view, we can get the hilly region look like that. Okay, it's a hilly region, and solve is identify about the angle from the plane surface. How much angle from here? It calculated the angle, or in unit is the degree about that. Okay, so as well as we can also talk about the another is that it's also called the aspect. Okay, so for that aspect, for that I simply search here, suppose trend dot aspect. So basically this type of input such as solve or hillshade or aspect, so this type of term mainly we are using for the different types of terrain analysis, as also drainage analysis. Lot of time, lot of analysts you can see they are using the hillshade, solve or aspect. So this type of data we have to need when you want to make the drainage analysis or also do for the terrain analysis. Then there's a lot of use for the hillshade map, solve map or aspect map. Lot of time, there's a lot of use for that. Okay, so now I create the aspect map.
Okay, sorry.
Yeah, please.
Yeah, for this, you also mentioned it minimum amount and also the maximum amount.
Yes.
Like minimum was 0. What it mean that physically? Yes.
Yeah, minimum it means that it will be above the surface level. Okay, suppose start from
Yeah,
the surface level.
yeah, surface level, and after 300, it show us like in yellow color. It mean yeah.
And maximum in this time there are the two way. Basically in this time I set the visualization totally on my own aspect. Okay, so but if you want to know about your, for suppose you want to work for the Bangladesh region. Okay, then first of all you have to calculate what is the maximum elevation for the Bangladesh and what is the minimum elevation for the Bangladesh. Then you can simply put your mean and max value, then it will so better. In this time I put this value randomly. Okay, so I put the value, it will be sea level, up the sea level and up to 300 meter. In this time I show that
Yeah.
it will be sea level and up to 300 meter, but if you want you can use it at 350, there is no problem about that. Okay,
Yeah,
so
understood.
using this,
For,
friends,
yeah,
please.
if we want to calculate for one reservoir, like we want to know about the base level, can it work?
Okay, you can also work about that for the specific region, and when you want to calculate it, the mean and max value for this region, you can easily get the value for that. What is the maximum and minimum value we can easily get from here.
No, I mean that when we want to calculate for one reservoir, that it take from the surface of water or the bed of water for one dams.
Surface
Like
of
we
water.
want to
Surface of water. For the bathymetric, we have to use the another algorithm to identify this elevation. But in this time, it only work for the surface. From the surface, it's calculate that. Yeah.
Yes, understood. Okay.
Okay. So now we talk about the aspect map.
Excuse me.
Yeah, please.
Yeah, I have another question. Like here, you have represented it in the range of 0 to 300. However, in the image, I mean this DEM which you have imported, there we have seen that it was in the negative also. It was present. I mean the values were negative also.
Yes.
So in this range of 0 to 300, how those negative values were represented?
Okay. So in this time, it not showing only for this specific pixel value 0 to 300. Okay. In this time, this map is not showing about the 0 to 300 pixel value. If you want to check, we can get some negative elevation or negative DEM. You can see. Suppose, yeah. So for this region, when I check the result, suppose in this time I click on here, negative 29. Okay. In this time, it's not showing. Basically, it is a randomly visualization. Okay, not
No,
showing
no.
the,
My question is
yeah.
like, my question is like that negative minus 29. How it is represented in that range of 0 to 300?
Okay, so basically in this time, it's showing for that all of those pixel value. Okay, showing all of those pixel value, not only for this range, not only for this range. You can see when I check the other region for the highest elevation, for this region, you can see it's showing the sometime 5,000, but I said the only for the 3. Why it's showing the 5,000? Okay, so it's showing all of those pixel value, all of those range, all of those things in the data set. But for my understanding, for the visualization, for my visualization, I show this value. And you can see here, if you want to check the dataset information, suppose this dataset information, they're already declared a value. It will be minimum minus 10 and up to 6,500. Okay, so within this range, I got this result all time.
No, that
Within
is
this
fine,
range.
I understood. But my question is like you are representing it in the range of 0 to 300. So 0 means 0 meter, 300 means 300 meter,
No,
right?
no, it's not.
Okay.
It's not. It's that wrong information
So
about that.
what is that 0 to 300 then?
It's my basically it's showing my visualization. Okay, 0 to 300 meter. Okay, within this range.
In place of 300, can I put 10?
Yeah, I can change it. There is no problem.
Okay.
Okay,
So
basically
it is not the true value. It is not the true value, right?
yes, it's not a true value.
So
Yeah.
so if I want to represent it in the form of true value, what should I do?
What value you want to show?
Means true value, the negative minus 29 or whatever the true value of elevation is there. So if I
First
want to
of
see
all,
the true value,
you have to calculate that using the reduce region function. Okay, using the reduce region function, first of all, calculate about the true value for your region. Okay,
okay.
then put here the
Can,
mean
can,
and
can you show us, I mean, how we can do that?
okay, so I already discussed about that how we can easily calculate the minimum, maximum, and average pixel level for a region.
No, not that one. I'm asking that can you show us how to represent the true value in the form of visualization? I mean, like, suppose let's say you are putting the minimum value as the one which was shown in the data file. In the data file, if you see the under the band, if you go, you are showing us the
Yes.
minus 10 to 6500.
Yeah.
So if you put the value in the visualization as minimum minus 10 and maximum 6500, what it will show?
Okay, so you can check it. There is no problem. Okay, so you can check. Okay, so now we can get the result look like that.
This is which layer? Layer 1.
Yes, this layer.
So again, it does not mean the true elevation value here, right? It is only the visualization.
Yeah, only for the visualization.
No, I mean, like, if I want to show the true elevation in the form of color, what should I do?
Okay, for that you have to download the data and also import the ArcMap software. Then you can get the what is the exact pixel value. You can get that.
So that cannot be done in Google Earth Engine.
No. Done it, but you have to use the calculate the pixel value first of all. Suppose for this whole suppose when you want to work for the specific region such as Bangladesh or other country, for this region, for suppose for this Bangladesh region, what is the maximum pixel value, what is the maximum pixel value of the elevation, what is the minimum pixel value of the elevation, you have to calculate that first,
No,
then
if I
put here.
calculate that, then how will I represent that in the form of color map?
You can use any color, okay, there is no problem. Yeah.
And last question, can I do this watershed delineation in Google Earth Engine?
Yeah, of course, yeah, it also possible.
Okay, will you show us that,
No,
that thing?
no, it's also another part of our online training program.
Okay.
Okay, so basically in this time I show you that only for that how we can easily make the hillshade, SOLP and aspect map. But using this hillshade, SOLP and aspect map, we can also create different types of delineation analysis or train analysis or other types of hydrological analysis. Okay. Okay, so now we talk about the aspect map. Just I can simply copy. Just copy and then simply call my DEM dataset image. And then give a variable name. So I use here this sea level. From the sea level, I want to show here success 300 meters. Okay, so now it's show the aspect map dot at layer. Simply copy this. And click to the run. Okay, so now you can see we can get the aspect map for the whole world. And mainly you can see when again the train is a flat, there is the no stop. Okay, so you can see I simply show you that one by one. Suppose for such as Bangladesh, for this region you can see it's totally flat, there is a no hillshade area or other things. So for this region you can see there is a totally flat, there is the no hilly region. Okay, this totally flat region. Okay, so for this flat region where I did not get any types of solve. Okay, you can see there is a no solve, okay, for this flat region, but some part also hilly in this region, so that's why I can find out the solve in here. Okay, such as hilly region we can get the solve in here. And also you can see the aspect. Yes, so now you can see we can get the aspect map. Okay, so basically using this type of different types of solve, aspect or hillshade, we are using for the different types of hydrological analysis for that water delineation, and then different types of train analysis we are using that. I will send you the link about that. What is the meaning of the aspect, what is the meaning of the solve, what is the meaning of that hillshade. So this type of analysis and how and what types of map, what the information you can get from here. You can simply follow this link. I sent that. Then we can easily get the idea about that. What is the solve? What is the hillshade? What is the aspect? Then you can easily work with that. Okay. So in this time I can get the result for the whole world, but I need for the result only for the one specific country. So for that, what can I do? Just I simply import my region. Such as I simply import my boundary shape file. Suppose I need the result for the whole country boundary of Bangladesh, such as I simply import the Bangladesh country boundary shapefile first and give this name such as ROI. Okay. So in this time, I just simply clip with my shapefile with ROI. Just simply use add the clip. So first of all, this is the DEM dot clip. Clip with ROI and same clip with also ROI. Simply copy and paste here. And also clip with the solve and clip with aspect. Okay, so now I can get the result only for this specific boundary of Bangladesh. Okay, and from here, when you download this map as a TIFF format and import in your ArcMap software, then you can get the true value, your elevation true value. Okay, so in this time, it's showing the visualization which I set in here. We can get the visualization. But when I want to download the TIFF image and import this image in the ArcMap software or QGIS software, then it automatically showing about the what is the highest value for the elevation, what is the highest value for the hillshade, what is the highest value for the solve, what is the highest value for the aspect map for the Bangladesh. We can get the result automatically when I import that. So in this time you can see this is the map I created from here. So it's a hillshade. Yeah. So we can get it is a totally flat plane. We can get the some hilly region in here. You can see. Also get the some hill in this part. We can also get the some hill. Okay. Also get the some hill also in here. Okay, not big. Also you can get some hill also in here. Okay, so this is the totally flat plane. We can get the some hill in this region. We can easily identify. So it is a hillshade map. Okay, from here. And this map created from this DEM. Okay, and basically this DEM is the 30-meter DEM. As well as you can also buy some any other DEM such as LiDAR data and also work with that in Google Earth Engine platform and also make the hillshade map, solve map or aspect map. As well as also you can use here the Star DEM. This is the high resolution DEM than NASA SRTM dataset. You can also use it. Then you can also get the better train analysis or better water delineation or other types of hydrological analysis you can easily do using this type of high resolution DEM about that. So in this time it's a 30-meter DEM. So that's why I can get the result.
How about Amsterdam resolution?
So Star, it is that, okay, I check the dataset. I show you that just a minute. I simply search here. Star. Okay, so yeah. So star 11 radians, it is the star can collect the data 14 spectral band from the visible thermal infrared. Okay, 60 into 60 kilometer. Yeah. Star global digital elevation model data. Check it. Okay, so star global digital elevation model data. Okay, so in this time, this is star data set. Yeah. So this is our data set link. Just I simply copy from here. Okay, copy that and paste in our code editor. Okay, so it's imported. So now I want to check about that pixel area. So take a variable such as scale. Simply copy this variable name and paste here. We use that this projection nominal scale. So now print that scale area. Okay, so it's also 30 meter. Okay, same pixel area about that. Okay, but I think this data Astra data is also developed than NASA SRTM dataset. Okay, so it is a 30 meter. Okay, and same approach we also get this dataset for the globally, and using the suppose in this time it is the Astra dataset, Astra, and we are also using the same approach when you want to use the dataset and make the Hillshade map or solve map or aspect map. Just apply the same approach. Okay, but I think this dataset is also developed, so that's why we can also get the better result than NASA SRTM DEM when I use the Astra. And I think this dataset is in this time this dataset is only available for the Google Earth Engine community. Okay, community data catalog in this page, and this dataset is not available for that catalog page. Okay, only for available for the community Google Earth Engine community catalog. It's available the dataset, but it's not added in that the Google Earth Engine data catalog page. Okay, so that's why you have to collect the data from that community. Okay, so because a lot of data we can also get in the community, this dataset we can only found in here, but it's not available in the Earth Engine public data catalog. Okay, suppose in this time they are working on the dataset with in the community, and after that when it will be successfully done or all of this process will be done, then it will be uploaded in the main Earth Engine public data catalog page. So that's why you can easily search in here, we can easily get the data. So I think now this dataset is also processing about that, and also you can see the dataset license and who created the dataset. All of this information you can get from here. Okay, and we can easily use the dataset in Google Earth Engine platform. Okay, so this is the community about the dataset. We can easily import our any dataset. Suppose you want to create any types of a dataset, it can be land use, land cover, or any types of dataset you can create. You can easily upload your own dataset in this community and also contribute in Google Earth Engine platform. Okay. Okay, so this is a 30 meter resolution, and basically you can see projection and nominal scale. So basically these two types, these two function we are using for checking the pixel area. Pixel area means that resolution. Okay, for projection and nominal scale. Any images when you want to find out the what is the pixel area or what is the resolution of the satellite images, just simply use that the projection and nominal scale and print that. Then we can easily get the scale or pixel area about this data set. Okay, so this is the process for working with the DEM dataset. Okay, for the creating the Hillshade solve or aspect map. Not only for that, there are the lot of analysis for the trend analysis also available in Google Earth Engine platform. Also for that, we can also do for that delineation. Okay, watershed delineation. Lot of things we are also doing in Google Earth Engine platform. Okay, so in this time I simply check about all of those data set. Okay, and also use for the data set for my region of Bangladesh. Okay, so from here you can easily export this data as a TIFF format and work with the ArcMap software or QGIS software for your map or other types of work we can also do using the Hillshade map, solve map, and aspect map. Okay, so any question? Any question? Okay, so now I simply go to my next slide. Okay, so now I talk about that how we can easily remove the cloud from the satellite imagery, mainly Landsat and Sentinel. Process is the same, just we have to change the band name. Okay, because Landsat and Sentinel, we can get the some difference, their image properties, and also get the some difference in their band name. Okay, otherwise all of those process will be same. So basically here you can see this is the one kind of satellite images. You can see we can get the some cloud pixel value. Okay, but when I apply here the cloud marks band function, I can get the very clear satellite images, and unnecessary cloud, or we can see the haze, different types of haze will be removed. We can get the very clear satellite images in here. Okay, so in this time we talk about that how we can easily create the cloud free image. So so in this time there is a lot of way for getting the cloud free image. In this time we are applying the cloud marks band function. Okay, using the cloud marks band function, how we can easily remove the cloud, we also try to discuss about that. Okay, so first of all I show you that Sentinel imagery. So for that I simply search here Sentinel 2, and I want to work with the Sentinel 2 multi-spectral instrument level 1C, this data set. Okay, so in this time I want to use this data set and then remove the cloud from here. Okay, so first of all I simply import the data set. Click on here import, it's imported. I put this name such as S2. You can put any name. So now suppose this data set I want to need for the specific region of interest is that Dhaka city, and I put the name such as Dhaka city, variable name is that ROI. Okay, so now let's display the image. Okay, so take a variable, suppose I put the name is the image, and then first of all call my collection S2. Okay, lot of time I discuss about this code for that filter bounds or filter date, filter metadata. I just simply put here that ROI, and then use here filter metadata, filter metadata. Okay, so in this time I simply go to this image properties. So image properties, I need to the cloud pixel percentage, simply copy that. So put here this such as less than, suppose 1. Okay, so now I also use here this filter date. Suppose I put this time period such as 2000, suppose 2016, 1st January from 2016 December such as 31. Okay, so now all of those images I create the median composite and then display with my clip with my shapefile is that RY. So now display this image. So use our map dot add layer and call this image, click to the run. Before that I also focus the center of the shapefile. So use at the map dot center object. My object is that RY. Click to the run. Okay, so it loaded the image, but we can say the image as a black color. So for that we need to add the visualization. Okay, so let's go. We add the visualization. Click on here and add here the such as red, green, and blue. Custom stress 98%, and then apply it. Okay, so and also import that. So simply copy that and paste after the object name. Okay, so I set it. Okay. So now in this time here you can say I can get the image look like that, and this image is not much cloudy, but we also get the some haze. You can see this type of haze. Okay, in this time suppose okay, so I just simply increase the value. Suppose in this time it is the 1%, I put here the suppose 90%. So I increase the value about that, then click the run. So now we can also get the some cloudy pixel value on my satellite images. Okay. Okay, you can see there's a lot of cloud pixel value. And you can see here, this is the white pixel value, means the cloud. Also, you can get the some haze. Here you can see cloud and haze we can get in here. So in this time, this type of, you can see cloud, a white pixel value cloud. Okay. So basically, you can see in this time, when I put here the 1%, then it also reduce the cloud. But when I put here the 90%, then it also increase the cloud and also increase the haze. But sometime we also need to increasing this value. Suppose you want to work with the coastal region and also work for that river bank. You need the satellite image for the coastal region or river bank. You can check it. 1% is not available. Then you have to increase the value. Suppose 5%. You can also check 5% is not available. You can also increase the value. Suppose 10%. You did not get the any satellite images which are available for the 10% cloud cover for the coastal area or river bank for your region. Okay. Then you have to increase the value. Okay. Suppose in this time I increase the value 90%. But when I increase the value, then some cloud and also some haze add with in my images. Okay. So some cloud and some haze in add my images. But when I use this satellite image for the land use land cover classification, then it hampered my result. Okay. So this type of cloudy pixel value will mixing with the build up area or barren land and totally destroy this land use land cover classification accuracy. Okay. So in this time, when you want to work with for that this type of situation, you have to increasing the value. You must use here the cloud max band function and then remove this type of unnecessary pixel value such as haze and also cloud pixel. Okay. So now how it will be work. So let's go about that. So mainly it's maintain the algorithm, CF max algorithm. Okay. CF max algorithm. Using this algorithm, it removing the cloud. Okay. So the algorithm is a lot of other equation. In this time, I'm not going the depth about the algorithm. Just show you the process how we can easily use this algorithm and remove this type of cloud. Okay. So let's go. You can see I simply open my image information. Okay. So in this time, I simply click on the band. In this time, in this band here, you can find out a one band. This band called the cloud max band. Okay. It's called the cloud max band. You can see cloud max. Okay. It's called the cloud max band. And this band name is that QA60. Okay. And this band has a total 3 bit. Okay. Bit 0 to 9, mainly it unused. Okay. Sometime when they are developing this, then also add the 0 to 9 different types of bit or signal. In this time, bit 0 to 9, it's really unused. And bit 10, we can get this opaque clouds in here. Also, you can see the bit 11, we can get the slash cloud in here. Okay. In this time, bit 10, you can get the two signal, 0 and 1. Okay. 0 means that no cloud, and also means that 1 means that cloud present. Also, you can see bit 11, the slash cloud has also two signal, 0 and 1. So 0 means that no slash cloud, and 1 means that slash cloud present. Okay. So in this time, first of all, I need to select this band. Okay, QA60. I need to select this band, and after that, select bit 10 and bit 11. Okay, and then bit 10, I need to set equal to 0, and also set bit 11 equal to 0. Okay, so then it indicating the clear condition of your satellite images. So first step, we have to select the QA60 band. It is our cloud max band name. Not only for that, when you want to work with the Landsat image, okay, I also compare that Landsat image also. Landsat image, we also get the cloud max band. It's named the pixel QA. Okay, so I simply open that such as from that browser. Okay, so I simply open the data set for the Landsat 8. Then we can also easily compare about the two data set and it will be completed. So Landsat, you can see Landsat have also band for the cloud max. It's called the QA pixel band. Okay, QA pixel. So in this time, I simply open that. Suppose Landsat 8. And suppose I work for the surface reflectance, click on here. Okay. So here you can see the one band name is that. Yeah, QA pixel. Okay. So QA pixel, it is the cloud marks band. And mainly it work for the shape marks algorithm for removing the pixel quality, all of this unnecessary pixel, and we can get the better image using the QA pixel band. In this time, this is my band name for that Landsat. And when I click on here, I can get all of those bits. In this time, you can see here the bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7, bit 8 to 9. And also some bit has some signal such as 0 or 1. 0 means that cloud or deleted cloud bits are set. 1 means the cloud and deleted clouds are not set. Also you can see 7, bit 7 is the water. Bit 8 to 9 is the cloud confidence. 0 is that none. 1 is the low. 2 is the medium. 3 is the high for the cloud confidence. Also you can see cloud shadow. Okay. 10 to 11. Cloud shadow confidence. Okay. 0 for the none. And then also you can see the 1 for the low, medium, high. Suppose when you want to work with the glacier region, we can get the snow or ice confidence. Okay. So in this time, we can get the some bit and also get the some signal 0, 1, 2, 3, this type of signal. Okay. And one signal means that one information it included in here. So in this time, when I work for the Sentinel here, you can see in this Sentinel, we are also get the same things. For that, we are also get the cloud marks band name QA60. And under this band, we find out some bit. Yeah, the cloud marks band name, and under this one, we can get the some bit. Okay, so in this time, we are using this cloud marks band name and also work for the bit. Okay, and then when I set the bit 10 equal to 0, and also need to set bit 11 equal to 0, then for the Sentinel-2 imagery, it's indicating the clear condition of satellite imagery. Okay, so now how I can do that? We also try to discuss about that. So first of all, I simply copy this band name US60 because I need that, and then open my code editor. So in this time, I need to create a function. Okay, so I need to create a function, and all of those things I need to add in this function. Okay, so when I create this function, and after creating this function, I just simply add this function with my image collection. Then all of this cloud will be removed. So let's go. First of all, take a variable name. Suppose I put the variable name is the marks2 cloud. You can use any variable name. After that, take a function keyword, and then give a element name. Suppose img. You can put any element name, and then put here this curly bracket. In this curly bracket, I just need to write my argument. In this time, my first argument is that I need to select the cloud marks band name QA60. This band I need to select. So take a variable, suppose QA, and I call this element name img, and then select this band. Okay. So QA60, I simply select this band and store it in this variable QA. Okay. So after that, I also need to select the bit number, bit 10 and bit 11 for this Sentinel. Okay, bit 10 and bit 11. So take a variable, suppose cloud bit marks. You can use any variable name. And when I set the bit, for selecting the bit number, we have to use this symbol. First of all, I select the 1, then less than bit number 10. Okay, so basically this is a symbol for selecting the bit number. First of all, you have to put here the 1 all time. Okay, it's not only for the Sentinel, it also for the Landsat image also same. First of all, select the 1, and then put here the less than, put the bit number 10. Okay, and do for the same things for the selecting another bit. So take a variable, suppose cirrus bitmax. I put this variable name cirrus bitmax, and the same, select the 1, then less than, bit number is that 11. Okay, in this time I select the bit number. Suppose when you were the landscape image, then you can see there are a lot of bit numbers. Suppose a cloud shadow bit 10, then you can simply select the which bit you want to need. Okay, select your bit. Okay, then in this time, after selecting the bit number, I need to set bit 10, mainly cloud bit max. It will be stored at the cloud bit max equal to 0, and also slash bit max equal to 0. 0, it's mainly signal. Okay, 0 means that there is the no cloud, or also for the bit 11, 0 means that there is the no cirrus cloud. Okay, so now in this time I just do that. So for that, take a variable, suppose the max, you can use any variable name, and then first of all I simply call this band, simply copy this band, because QS60 mainly this band is stored at the bit 10 and bit 11. Okay, so bit 10 and bit 11 under this band of QA60. So just I simply call the QA, and now this band I need to connect with the bit 10 and bit 11. Okay, so this is the band QA which is stored at the QA60. In this time I need to connect with the bit 10 and bit 11. Okay, for connecting that we have to use a function, this function called the bitwise end. I mistake some spelling in here, so it will be bitwise, okay, uppercase, okay, bitwise end. This is my band, and this band has a bit 10 and bit 11. In this time this band I set with the bit 10. So for that I simply call the bitwise end function, and then copy this variable name and paste here. Okay, after that I need to set here the equal to 0 signal. Okay, from bit 10 has a two signal, 0 and 1. So I simply set equal to 0. Okay, now also do for the same things for that cirrus bitmax. So I use here the end function, and then simply call the QA. This QA I set with the bit 11, mainly the cirrus bitmax. So use at the bitwise end, and call this cirrus bit. Simply copy and paste, and after that also set equal to 0. Okay, so now you can see, first of all I simply select my QA60 band, then select the bit number 10 and 11. After that this bitmax, cloud bitmax equal to 0, and also cirrus bitmax equal to 0. So it's identify that indicating the clear condition of satellite imagery. When I put this type of function, it indicating the clear condition. So I write my function. Okay, now from this function what I can get, I need to return it. Okay, so what I return from this function, so I need to define it. So use at the return function. So return, in this time I returned my image update. So use at the update max function is using this condition. Okay, using this condition I just update my image, and this condition is stored in this variable max. So simply copy that and paste here. Okay, so now this function is ready. Okay, so now when I just simply add this function I add with my image collection. This is my image collection. Then I can get the clear satellite images, and all of those unnecessary cloud pixel will be removed. Okay, so now how I can connect that. So in this time, I want to show the difference about the two images. So just I simply copy the same things from here, simply copy, and then paste here, so that you can easily difference between the cloud image and cloud free image. Okay, just paste here. So in this time, I simply change the variable name. Suppose if I put the variable image such as cloud free. Okay, simply copy that variable name and paste here. Okay, so now this is my function which I created. This function I need to connect with my image collection. So just I simply use a function. This function called the map function. Map. Okay, and simply copy the variable name of this function. Simply copy and paste here. So now it's set it. Okay, so now we check the result. You can check, click to the run. What happened? You can check. Okay. I'll put the layer name, little better. Suppose I put this layer name such as it's a cloud free, and another layer is I put the another image layer for that. Cloud image. Okay. So now click to the run. In this time we can get the two layer. Okay, one layer I add the cloud marks when function, another layer I did not add that. So now you can see, okay, so you can see this type of cloud will be removed. You can see for the new layer which I add in here. Yeah. Also you can see all of this haze also removed from here. So I also open that. You can see this is a cloud free image and it's a cloud image. Also haze you can see. But when I open the cloud free, it will remove all of those unnecessary cloud pixel. Remove. And also remove the haze from here. We can get the very clear satellite images from here. Okay. So basically this is the process when you want to use here the cloud marks band function. It also available for the Landsat and also available for the Sentinel. For removing the cloud and haze from the satellite image. Okay. So anyone any question about that? Okay. So you also try to for your own region for removing the cloud. Okay. So basically in this time you can see the result for that, and you can use the same code. Okay. There is no problem. Just simply copy the function variable name and add with your image collection. Then I hope it will be work. There is no problem. It will work, and we can get the cloud free images from here. Okay, so I also show you the another example for the Landsat imagery. Okay, so in this time I talk about that another topic for the land surface temperature. When I talk about the land surface temperature using the Landsat imagery, then I also show you that how it will be work for that Landsat imagery cloud marks band function. Okay, so in this time anyone question? Okay. 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 So now And I simply go to my next slide. Okay, so now I talk about that land surface temperature, how we can easily monitor the land surface temperature using the Landsat imagery. So just I simply open a new code editor.